Okay, so on this quiz we have two very basic Newton's second law problems. Okay, the first one is just an F equals m times a problem, but we have to calculate the acceleration before we can solve it. Okay, second one is an elevator question, and we went over a whole bunch of those yesterday. Okay, so they should have seemed fairly familiar to you. All right, so our first one here is one of these like Guinness World Record kind of things where this guy physically pulled a C-130. Okay, which is like one of the largest, heaviest planes that somehow gets in the air. Okay, and this guy was able to pull it, okay, using just his own strength, which is impressive. Okay, that's like full beast mode. Okay, totally. Okay, all right. So here's what we got to look at in this question. First off, which mass is he accelerating? No, he's not. He's not part of this. Okay. Now, I know you're thinking, well, Mr. Coder, he said when they were all attached that we could, we would consider this, but it asks, okay, he's pulling on the plane. Essentially, it's just the force he exerts. He's not really part of it. Now, in the end, because his mass is so small compared to the mass of the plane, if you actually added his mass in there, it wouldn't have made any difference to the answer. He's 55 kilograms. Okay. Actually, it doesn't even say that in there, does it? No, took it out. I originally had it in there. Okay, so we have just the mass of the plane, okay, and we're just going to put in the information that we have. So the aircraft starts from rest. So VI is 0 meters per second. It's pulled for 60 seconds and reaches a final velocity or final speed of 0.31915 meters per second in a forward direction. All right, so we got a positive value and a time. Can we calculate the acceleration with those? Okay, so acceleration is going to be VF minus VI over T. So 1 mark for givens. Okay, oh sorry, and we have the mass of the plane, 188,000 kilograms. Okay, so we plug in our numbers here for this calculation, and we are going to have 0.31915 minus 0, okay, divided by 60 seconds. 0.31915 divided by 60 seconds, okay, is going to give us an acceleration of 0.005319. Right, I'm not going to write all of those numbers. Sorry, 0.005319. Okay, so we'll give them a mark if they have this acceleration calculation somewhere, okay, and that's meters per second squared. Our next thing is how much force was used? Well, F net equals mass times acceleration, okay, which is going to be then 188,000 kilograms times that acceleration we just calculated, 0.005319. Okay, so they can have a mark if they have that step somewhere. Okay, times 188,000 kilograms. Okay, gives us a force of exactly 1,000 newtons. Okay, which actually isn't all that much, because this is operating in the perfect physical world where he doesn't have to overcome any rolling friction or anything like that, which he would actually have to use in the real world. So that force would be much greater than that in the real world. In the perfect physical world, it actually would only take that much force, so 1,000 newtons. But we only have two significant figures with the 60 here, so it'll be 1.0 times 10 to the 3 newtons. The fourth and final mark on that question there. Questions on number 1? Okay. Question number 2, 60 kilogram person stands in an elevator on a scale, and I kind of showed you this at the end of class yesterday. Okay, what does the scale read when I stand on it? I'm not looking for the number it read yesterday. Okay, it reads your weight. But if I'm standing in an elevator, it's telling me how hard the floor is pushing up on my feet. Okay? Because the scale works like this. I step on it, gravity pulls me down into it, and there's a spring inside that pushes back with an equal amount of force. So actually what the scale reads is the upward force in the spring inside the scale. Okay? It just happens to also be equal to your weight being pulled down by gravity. All right, so what we know here is, with a free body diagram, here's our 60 kilogram person, that we have an upward force of 520 newtons. We also have a downward force, which is gravity. Everybody okay with that? Okay, give them a mark if they've got a free body diagram. We're also going to give them a mark for calculating the force of gravity. So m times g, 60 times 9.81 is 588.6 newtons. So we'll give them a mark for that. All right, if I want to find the acceleration of the person, I need to find the net force. That can be m times a, or it can be the sum of all forces. Okay, so I'm first going to do the sum of all forces. F net equals 520 plus 588.6, but that 588.6 is negative. Okay, so if they have something about the sum of all forces there, okay, they can have a mark for that, which means our net force is going to be negative 68.6 newtons. Okay, everyone all right with that? Our next calculation then, F net equals m times a, so acceleration equals F net divided by m, 68.6 divided by 60 kilograms. All right, so they can have a mark if they show some kind of F equals m times a manipulation there. And we're going to get for an answer here, 68.6 divided by 60. So their acceleration will be, what do we got, 2 significant digits here? Yes, 60 kilograms. Okay, so 1.1 meters per second squared. Down. If they don't have down, it is wrong. Force is a vector quantity and thus must have a vector quantity. Okay. So that's their 5th and final mark there. Quizzes out of 9. Are there any questions on number 2? Okay, please give them a mark out of 9. Let them see it, and then bring it to me.